Dear students, good morning. We already discussed about one chapter, that is trigonometric inverse functions. I know, I can understand that chapter is somewhat difficult. It is purely based on the first four chapters: ratios, compound angles, multiples, submultiples, and the transformations. It is containing so many of formulas, of course. On that basis, here in the second PU, that chapter is there. I took that chapter because it is, of course, important and a difficult one. Because it is connected with the previous trigonometry. That is why I took that one. The students may follow it in a good manner, smoothly. But afterwards, I feel that it is somewhat inconvenient, because most of the students of you are not well versed with the basic formulas of trigonometry, which are in the first PU. So that is why that chapter may give some inconvenience. Of course, it is for time being. After reopening of college, the lockdown will be cancelled. After that one, we will take that chapter and we will clearly discuss. No need to worry about that one. You please try to understand it now. Okay, na? Okay. Leave it out. If you are willing, I will conduct the exam in that chapter. Otherwise, we leave it out. That is not the main criteria. Okay, na? Right, leave it out. Now, very simple and easy chapter, that is the matrix. Single is a matrix. Plural form is matrices. M-A-T-R-I-X is a matrix. It is single. Here it is matrices is a plural form. Matrices. Okay, now this is a very simple and easy chapter. We can easily follow. Okay, now. Now I want to discuss today that matrix chapter. This chapter is containing a total 9 marks. Okay, now that is 1 mark bit plus 3 marks and a 5 mark question. Okay, now you know that the pattern. As usual, the first year and the second year. The first PU and second PU, the pattern is same. This matrix is 1 mark bit is there, and 3 mark question and 5 marks also is there. Okay, na? That is this chapter. Very simply we can solve this one. We can discuss. Here, in order to discuss about the matrix, matrix is a group of numbers. Okay, na? They are arranged in rows and columns. It's very funny chapter. Very easily you can understand. Okay? You see, in order to explain, to introduce that chapter, I want to take one example. Already I wrote on the board there. Already it is given. Okay, na? Just I can read and explain. Suppose a student, Kanchan, has 9 pens. A student is having 9 pens with her. That information, what is the information here? The student is having 9 pens. That information is expressed in other terms. We may express the above information that Kanchan has, the student Kanchan has 9 pens. Is expressed in terms of simply, it is a bracket. It is not a flower bracket, it is not vertical bars, it is a differently, it is just like a box. It is just like a box. Also it is called as box. The matrix. In the bracket we write a number. That number is related to the number of pens. You see, with understanding this notation, a box with a number inside. This gives a meaning with understanding that the number 9 which is in the bracket inside is the number that Kanchan has the pens. Okay, na? The number of pens that Kanchan has. Very clear. Orally or with the words we can understand the Kanchan has 9 pens. Instead of writing Kanchan has having 9 pens, simply we write mathematically one notation. A box or a bracket with a number. That number related with the number of pens that a particular student is having that pens. Not only pens, pencil, whatever it means. So here this is a matrix. Matrix is a group of numbers. In the bracket that number is mentioned. That number is number of pens in this case. For example, we take another one. To take it is another one. It is the first one. Take another one. The same student Kanchan has 9 pens and 12 pencils. Here 9 pens, 12 pencils. Two things are there. 9 pens and 12 pens. Two different things are there. The same information which is in this example 9 pens and 12 pencils having by the Kanchan student, that can be written as you see in the same bracket 9, 12. 9, 12. Not 912. The gap is there. 9 and 12. Vertical, horizontal I am writing. That gives the meaning with the understanding that this expression, this notation, which are the numbers are inside the bracket, is understanding with the understanding that Kanchan has 9 pens and 12 pencils. Or otherwise we may write it as not only horizontal, vertical also. The Kanchan has having 9 pens and 12 pencils. It is vertically I wrote the numbers here, horizontally I wrote the number. Okay, na? Whatever it may be, Kanchan or any other person or any other student or anything, if the information having some numbers, number of things, number of whatever it may be, those numbers can be put in one bracket, one box, horizontal and vertical. That gives the total information. Suppose 100 students are there, they are having 10 different types of things in different numbers. It is very difficult to write on the board or on the paper. Every time we have to read those 100 students and what they are having, the 10 different things in different numbers. It's very difficult. For that purpose, this chapter is introduced. Very simply, we write in this board that 100 numbers, 10 different things in different numbers they are having. Very simply we can. Okay, now that is the purpose of taking this matrix chapter. Okay, this is 1 and 2. Is it clear? Now we go to third one. Here also see there are 3 students, Kanchan, Rohit and Arun. Kanchan has 9 pens, 12 pencils. Rohit has 5 pens, 7 pencils. Arun has 3 pens and 4 pencils. What is meant? This information can be written in shortly or with notation. It can be expressed easily in the bracket. Those numbers 9 pens, 12 pencils, 5 pens, 7 pencils, 3 pens, 4 pencils. You see 9, 12, 5, 7, 3, 4. Okay now. Here I write that number of pens and number of pencils that having by the students Kanchan, Rohit and Arun. Here they are putting in a box as rows. I mean horizontally. Or otherwise the same information can also be written as the Kanchan, Rohit, Arun. Here it is vertically I am given. The Kanchan having 9 pens, 12 pencils. Rohit 5 pens, 7 pencils. Same Arun 3 pens, 4 pencils. Whatever it may be, that information is very clumsy. That can be easily, clearly it is given in the box or in the bracket. So we may say this is a matrix. The matrix is a arrangement of numbers in a horizontal and a vertical. Okay now? It is a group of numbers. Matrix means a group of numbers which are arranged in the horizontal and the vertical lines. Okay now? Like that we can introduce the matrix. Okay now? Yes. First. Okay, thus the matrix can be defined as I already noted here. You see there? Thus, the matrix can be defined as an ordered rectangular array. Array means arrangement. An ordered rectangular arrangement or group, rectangular array of numbers. Those numbers are real or imaginary or simply complex number or otherwise functions. I will clearly tell it. Next, you see already in the 3 examples previously I told you. In that 3 examples, pens and pencils, number of pens and number of pencils. That is real numbers. Sometimes we may use the imaginary. That means complex numbers are real and imaginary number also may come. Or functions. For functions also. In the numbers place cos theta, tan theta, e power x, log x, x square plus 1 or 2x minus 1, just like it will come. Simply you leave out that one. So an ordered rectangular array of numbers which are real and imaginary or functions, okay now, this is called as a matrix. That arrangement of numbers is called as a matrix. And the matrix, you know what is a matrix means? We have to tell that it is an ordered rectangular arrangement of numbers simply. Those numbers are real and imaginary. Or there may be the functions also. Is called a matrix. And the matrix always denoted by the capital letters. The capital letters, capital A, capital B, capital C, D, E, M, N, P, Q, R, just like etc. And the numbers which are included in that bracket, which are contained in the matrix, they are called as elements or entries. They are called as elements. It is elements. Or it is entries are also. Entries. But mostly we use elements. So, I write some examples. Number 1. Capital A is equal to 1, 2, 3, 4. Okay now? This is a matrix. This shape is a rectangle shape. You see, horizontal vertical. The numbers are in horizontal and vertical also. Okay na? So they are the arrangement of numbers in order rectangle. Okay na? Its notation is capital A. It is denoted by capital letters. Suppose B is equal to 1 0 7 9 8 some 10, just like you assume. It is also the numbers are set in which are inside in a box or in the bracket. Okay na? Which are noted in the rows and columns, horizontal lines and vertical. The shape is a rectangle. You may feel that sir, length is here, length breadth difference is there, but here is same. The square is also rectangle. Rectangle means it is general. Okay na? Leave out that one. Okay na? So the numbers are set in rows and columns, in horizontal lines and vertical lines. Okay na? That is given in the definition. The capital letters A, B. Not only this one. Suppose C is equal to, it is I plus 1, it is e power x, or otherwise I will get it. It is I, it is 2 minus I, it is minus I. Here totally these are imaginary numbers or complex numbers which are set in the box inside the bracket. It is also the matrix. Here the numbers are imaginary. Or capital D is equal to cos alpha minus sin alpha minus simply sin alpha, or it is cos alpha. Here the numbers are not, these are functions. Okay na? Or capital E is equal to e power x, e power minus x, and e power 2x, e power some 5x. Okay na? Here also it is exponential function. It is trigonometric functions. Like that we can give the examples. All are defined in capital letters, notated by capital letters. Okay, the matrix is always denoted by capital letters. And here the inside the numbers are real numbers, or image numbers, or functions, or it may be. They are called as entries or otherwise elements. Common we take elements. Okay na? Right. Here note. You see the note is observed. Here the horizontal lines is called horizontal lines, like this. These are horizontal lines. 1, 2 or 1, 0 or cos alpha minus sin alpha or e power 2x, e power 5x. They are called as rows. Whereas the vertical lines are called as columns. Okay, now they are called as columns. One is rows, another one is columns. Okay, now columns means vertical. Cos alpha, sin alpha, e power x, e power 2x, 2, 4, 0, 9, 10, I minus I. Like this. They are vertical and horizontal. Okay, now that is the thing. So the numbers inside the matrix is elements or entries. The horizontal line is called as rows and the vertical lines are called as columns. That is the thing. Okay, now? Yeah. ఉండు ఒక నిమిషం. Okay? Yeah. Here the next topic is order of matrix. Order of matrix is the size of matrix. In general, we may say in common or otherwise, mathematically definition, order of matrix is the number of rows and the number of columns contained in that particular given matrix. How many rows are there? How many columns are there? That is contained by the given matrix. That is the order of matrix. You see, for example, with the example you can understand it. Suppose A is equal to 1, 2, 3. This is 0, 1, 6. Okay, now there are 2 rows. This is first row, now it is first row. It is second row. Okay, now how many rows are there? 2 rows are there. Whereas this is first column. Okay, now column. This is second and it is third column. Okay, now here order is order. Here order is, you see, this is first you write number of rows and number of columns. Here columns are 3. Yeah, 2 rows and 3 columns. This is, you see, the 2. It is written as 2 into 3, but it is pronounced as, it is read as 2 by 3. Don't say it is 2 into 3. It is read as 2 by 3. 2 by 3 means not 2 divided by 3. Not is 2 into 3, 2 multiplication by 3, not that meaning. The notation is like that. The order is 2 by 3 matrix. It is read as 2 by 3. That means 2 rows by 3 columns. With 3 columns, 2 rows are there. First you mention the rows, number of rows, and then you mention the number of columns. So that is the order of matrix. You see, one more example I will give. You see that it is capital B is equal to, it is 1, 0, 2, 5, 6, 0, it is 6, 7, some 9. You see, there are 3 rows and 3 columns. Okay, now? Actually, that is order is equal to, it is 3 by 3. Don't say 3 into 3. This is 3 rows. It is pronounced as 3 rows by 3 columns. Try to understand. Okay, now? 3 rows by 3 columns. That is the meaning. And actually, this is mentioned here 3 into 3. 3 by 3. Here we have to. At the end, just like it is in the corner, you have to write. Okay, now? Matrix, after completion of matrix, you write in the corner at the end, 3 by 3. That is the order of matrix. Okay, now? Right. So, order of matrix is once again, it is a number of rows and a number of columns. Now, general form of matrix. Yeah, sir, this is important concept. Observe. A general form of matrix. Capital A is equal to, it is A11, A12, A13 and so on, A1J, A1N. It is A22, A is too much. It is A22, it is A23 and A2J. It is A2N. A31, A32, A33 and so on, A3J. It is A3N. And it's going on at the last, A M1, A M2, A M3. It is MJ and it is MN. In the middle, we may write it as one more, a general one. I will mention. It is AI1. It is AI2. It is AI3 and so on. It is AIJ and so on. It is AIN. Okay, now like this. And again, it is proceeding in this manner. Okay, now don't confuse. Here it is a general element. You see, try to understand. Okay, now observe. General form of matrix. It is a general matrix. Capital A, notation for matrix is capital letters. Okay. This by definition, all the numbers are there. Here A11, A22, A13. You don't confuse. A suffix. A suffix 11, not 11. A12, not 12. A13 you have to, A1Z, 1J, A1N, you have to write it like that. Pronounce it like that. A.21, 21, 22, 23, A33, AM3, not M into 3, I into J, not I into J, Aij simply. Like this, the elements are inside the bracket. It is a matrix. It is a general matrix. How many rows are there? First row, you see that. The always first number denotes the row. First row. This is second row, third row, ith row, mth row. Okay, now you see. Please try to understand. This is first row. Okay, now because the first suffix number. This is second row. How can you say? A2 is there, and it is third row, like this. Here it is, tell me, here it is ith row, I is there, I, first number is I. So this is ith row. Okay, now, like this it is going on, and it is mth row, m is there, mth row. So how many rows are there? In order to mention the rows and columns, order, m is the first. We have to mention the number of rows first. Similarly, you see the second digit in the suffix, that is one. So this is first column. It is column. It is first column. Here it is you see, it is a second column. Okay now, it is a 3. Third column. Okay now, like this is the jth column. Jth column. Okay now, and here it is n. It is a nth column. Okay now, like this. There are m rows. How many rows are there? M rows are there. And how many columns are there? N columns are there. Altogether, the order is m by n. Here we have to mention like this. M by n. It is m by n, not m into n. That is the size of a matrix. Generally we may say. What is the order of the matrix means? How many rows and how many columns are there? That is the thing. Okay now? There are m rows and n columns. Okay now? But here, each element inside the matrix is with a small letter. We have to write the small letter. You see, Nena, every element A, the suffix is containing 2 digits. The first digit is number of row and the second is number of column. Suppose if we take, here I will mention. Suppose I will take this number. It is A33, for example. What is A33? The element, you see, the element A33. A33 is an element, it lies, an element which lies in third row, okay na? Third row and third column, okay na? What is the necessary to mention that the suffix 2 digits means we can identify where it is situated. Suppose this one, M-A-I-J, it lies in ith row, okay na? Ith row and jth column. Okay na? Like this. Suppose here it is AM3. AM3 means it is the element which lies in the which lies in the mth row and third column. Okay na? Like this. Okay na? That is the meaning of this general form. Why we are taking that general form of matrix or general matrix means we can understand the element whose position is by like this we can mention. And the order is number of rows and number of columns. Okay na? Like that we can take the general matrix. Okay. Observe. Here, 2 examples are there. Through this solvation of 2 examples, we can easily understand what is the purpose of taking the matrix, discuss about matrix and how to express the matrix. We can easily understand. Try to. You see, in this example, we have to construct a matrix of order 2 by 4 and also 4 by 2. In 2 ways we have to express it. We have to construct. Where is the elements, numbers, entries means This is for any point p x comma y. Generally it is given x comma y are the numbers, x coordinate and y coordinate, which are the vertices of quadrilateral ABCD, where A is 1 comma 1, B is minus 1 comma 1, C is minus 1, and D is 1 comma minus 1 comma minus 1. Okay na? These vertices of quadrilateral we have to mention in the form of matrix. Suppose it is a matrix, we can easily these are the quadrilateral. We are given as a quadrilateral. Yeah, okay. Not a geometry. You see, in matrix we have to mention this information. Student. Suppose capital X is equal to the first matrix, first point 1 comma 1. Will agree? And it is minus 1 comma 1. It is about B. And the C point minus 1 comma minus 1. And D point 1 minus 1. Okay na? You will see, it is about the point A, it is about the point B, C and D. Okay na? For understanding I am writing A, B, C, D, but it is not necessary to mention like this. Here, once again you try to understand it. The quadrilateral with the vertices A, B, C, D, it's geometry okay. In algebra, in a matrix form, how can you mention? Means those x coordinate and y coordinate at a particular point is as a vertical. 1 comma 1 x coordinate and y coordinate about the point A, that is a vertex A. And here minus 1, 1, it is about B and about C and about D. Okay, na? Okay, this is the matrix. One row and the second row. So how many rows are there? 2 rows. And how many columns are there? How many vertical lines are there? 1, 2, 3 and 4. So this is a matrix whose order is 2 by 4, 2 rows and 4 columns mentioned by capital S, which gives the information that 1 comma 1 the first vertex of quadrilateral, minus 1 comma 1 second vertex, minus 1 third vertex, 1 comma minus 1 is the fourth vertex D. Like that. Or we may take it as also, or you see capital Y is like this also. It is 1 1 minus 1 1 minus 1 minus 1 1 minus 1. You see that it is about here na. The vertex A is containing 1 comma 1 and it is a vertex B minus 1 comma 1 and it is a vertex C, yeah, minus 1 and it is about D point, D vertex. Okay, now like this also we can mention. It is for understanding purpose I am writing this arrow marks and ABC. Actually this is not mentioned in the problems. And you see this is 4 by 2, its length, its size is 4 by 2. That is mathematically we call it as order of the matrix. 4 rows and 2 columns. Okay, na? 4 by 2. Whereas here it is 2 by 4. Okay, na? Through that one we can understand the size of matrix, the order of matrix. Okay, na? This is very clearly it is given in this example. Okay, na? Right. It is also asked in the dated. It is a dated problem. It is also dated problem. Now, it is important. It is a dated. Next, this problem you see, it is also a dated problem. Star notation I am giving. Solution. We construct a matrix whose size is 3 by 2, whose order is 3 by 2, 3 rows and 2 columns. And the element is differently, it is mentioned. It is differently. You see, Aij is the notation for element, small letter, with 2 suffix, 2 digits, I, j, not I into j. 1 by 2 mod of I plus 5j. You see, capital A is equal to matrix is Aij. Like this we have to mention. Okay, now it must be 3 into 2, where I is equal to 1 comma 2 comma 3, because I is related with the number of rows. How many? 3 rows are there. And j is it is 1 comma 2 only. That means there are only 2 columns. Now I want to calculate A11, the very first element in the matrix A11, first row, first column. That is 1 by 2 into I is 1 plus 5 into j is also 1. That is 1 by 2 into 6 is 3. Next, A12, first row, first column. First row, second column. It is 1 by 2, 1. I is 1, j is 2. 5j in the matrix definition is I plus 5j is 5 into j is 2. So it is 1 by 2 into 11. So it is 11 by 2. Can you find A13? A13 is there? No. Because J3 means the J is related with the columns, only 2 columns are there. J is 1, 2 only. So here it ends. So next 2, 1. Again second row, first column. It is 1 by 2. 2 plus 5 into 1. That is, it is 7 by 2. 2 plus 5 is 7, 7 by 2. Here 2, 2. Next. Second row, second column. It is 2 plus 5 into 2. I is 2, j is also 2. So it is 10 plus 2, 12, 12 by 2 is 6. Okay, now. Next, 2, 3 is there? No. J is not 3. J is only 1 and 2. So again we go to A31, third row, first column. It is 1 by 2. 3 plus 5 into 1. I is 3, j is 1. So it is 3 plus 5, 8 by 2 means 4. Okay, now A32. It is 1 by 2. A is 3 and 5 into 2 is 10 plus 3, 13 by 2. Okay, now try to understand. 1, 1 or 2. It is row only. 1 first row, first column, first row, second column. It is row only, first row. It is second row only. 2, 1, 2, 2. 2, 3 is not there. 3, 1, 3, 2. So all elements are there. Now the required matrix is, you see, observe. It is, how many 3 by 2 now? 3 rows, 2 columns. 3 rows means first, this is 3 and it is 11 by 2. It is 11 by 2. This is first row. And second row, it is 7 by 2 and 6. Okay, now third row, it is 4 and 13 by 2. Okay, now this is 3 by 2. In such a manner, we have to find the elements first according to the given order. According to the order, first number is related with the I, second number is related with the J. Through that one, we can find all elements and represent in the box, that is in the matrix which is required. Okay, now like that one can construct. Okay, now yeah, pass.